Hey, grade 6. So last class, what we did is we explored and introduced ratios, right? So ratios are, remember, are comparing two values, right? Two sets of values. So what we're going to do today is we're going to work on equivalent ratios. Before this video, please make sure that you compare your homework with the homework that I posted and make sure you have the right answer so you understand the basics before we move forward. Equivalent ratios. So as you can see here, right, we have two items, right? Two items. You have for every, so you have 3 parts of cranberry juice and you have 2 parts of apple. So 3 to 2 would be our ratio of cranberry juice to apple juice. Equivalent ratio is we take this original ratio that's here, 3 to 2, right? And we multiply them by the same value, and this becomes an equivalent ratio. So if we want to double the amount of juice, but we want the same ratio, right? Then we have to double it. Then this would be what our new ratio would be. And this is what we're going to explore throughout the rest of the slides. Before we do that though, this is a little review that I want you to do. So after I explain this, pause this video, attempt it, all right, and then we'll go over it. So basically what you have here is you have an image. You have a man in a white shirt and you have a lamp. All right, and I want you to determine what do you think the height of the lamp is, all right? So what is going to be the ratio? Pretend you didn't see that. That's all right. That's from the last time. All right, so based on what you know about ratios, that's comparing values, I want you to write a ratio comparing the man's height to the lamp height. All right, pause the video and just write a ratio. Okay, so as if you went back and you saw the ratio that I had 3M, and I said that 3 men to 1 lamp. And what the reason why that is if we draw, we have to first establish a base, right? And so what this has to do a lot of is estimation, scale, and progression. So if this is the height of 1 man, all right, we need about the equivalent distance in order to go up this, right? So from here to here, the equivalent distance is approximately right here, right? That is the height of a second man. And you have all this space to the very top. This is roughly the height of a third man. So remember, this is estimation. Is this perfect? Maybe not, but we're writing a ratio. So it's 3 men to 1 lamp. All right, so that's why we have a ratio of 3 to 1. Now for the second part of the question, so if the height of the man was 6 feet tall, using your ratio, how tall would the lamp be? And so already here what I have is you have 3 men, because remember it's 3 to 1, because we already know how tall the man is, which is 6 feet times the 6 feet will equal the lamp's height. Because we have 3 men equals 1 lamp, so then it's 1 lamp times, so 3 times 6, so the 1 lamp will equal 18 feet, 1 lamp. All right, so that has to do with estimation. What we're going to focus on though now is finding equivalent fraction. This is a bit of a review. So equivalent fraction, so what you have here in front of you, this is a ratio, so not, I know I'm saying fractions, equivalent ratios. So what you have in front of you though is a ratio table, right? And this is something that you'll need to use for today's, well not today's, but the assignments that are coming out on Thursday, right? So what you have here is you have term 1 and you have term 2. Term 1 will be the first object. In the last example, that was men. In the example before that, on the very first slide, that would be the cranberry juice. The second term, right? The second term in your ratio, it'll go right here, all right? 1, 2, and then you have different sections. So what you would then have, this ratio here would be 5 to 9, as we can see in our slides, 5 to 9. 5 something compared to 9 of something else, whatever that means, all right? What I want you to do is I want you to, so what, actually, not what I want you to do, what we're going to do, because you don't know how to do it yet, is we're going to go over how can you find ratios so up to, so the first term is less than 40, all right? So we have to increase this value here, so that it becomes less than 40. And if we do that, it's going to look like this, all right? It's going to look like this. So what we have here is we have the original ratio, right? 5 and 9. That's the original ratio. And we want to find all the equivalent ratios that are less than 40. So that the first term is less than 40. So as we saw in that first slide, as we increase this, so what I did is I multiplied that by 2, right? And as I multiplied it by 2, my multiplication signs are a bit sketchy as I use my trackpad, I have to do the same to this side, right? I'm going to use another color. As I then, the relationship between 5 and 15 is I multiplied this by 3. Oh, it's just loading. Sorry for this. Seems like I'm always going to have to, I'll use a darker color so you can see that better. All right, 5 and 3. This is going to be a 3. But you have to do the same here. For this 9, you multiply it by 3. We're not increasing this, right? But we are multiplying. Okay? So on and so forth. So we keep multiplying these numbers. This will become 4, 5, 6. Because remember, we want the first term that is less than 40. So all of the ratios that are equivalent to 5 and 9 would be 10 and 18, because both of those are multiplied by 2. 15 and 27, multiples of 3. 20 and 36, 4, and so on, all the way up to 35 and 63. Right? So that's how you plot them. This is how you plot them on a ratio table. Ratio. I told myself I wasn't going to write. So I'm going to stop at ratio. It's because I committed myself. Ratio table. Ratio T. I can do it to you. All right? And that's how you plot it. What we have here is a problem that you're going to have to be able to solve. Okay, so this is a recipe, and recipes are where you use ratios the most often. Okay, so this one makes honey cookies, and as you can see, I'm going to circle it right now. As you can see, these are our ingredients. So this is everything you need to make a honey cookie. I've never made this this recipe. I don't even know if it's good. If you have free time, maybe you can try it. It isn't actually. I have all those ingredients. Maybe we'll see if I can make that. All right. So what I'm more concerned about though is does this recipe taste good? More of how can I make more of it? All right. So right now what you have is you have the ratio of honey to eggs. Right? Is you have for every 2 cups of honey to make this recipe you need 3 eggs. Right? For every 2 cups of honey you need 3 eggs. So the ratio is 2 to 3. How do we make this recipe? So let's say hypothetically this recipe makes 12 cookies, okay? We want to make 36 cookies, which is 3 times that amount. All right, what do you think we need to do? I want you to pause and I want you to try to figure this out. All right, so pause the video and try to think of how can I change this ratio so I can make 3 times the amount of cookies. All right, so if what you're saying is we should multiply the numbers by 3, you'd be correct. So let's go to the next slide. All right, so what you do is you multiply the numbers by 3. So you're going to multiply always the originals, the 2 and the 3. You're going to multiply this by 3, which becomes 6 and 9. All right, and that's so 6 cups of honey and 9 eggs is the ratio of honey and eggs you need to triple the amount of cookies. All right, so we're just finding equivalent ratios because what you want to do is you want to maintain that ratio. If you just increase it by adding 3, that's going to be 5 to 6, and you're actually throwing off the ratio, so it won't taste as good. That's why you have to maintain your ratios in cooking. Here are some examples. I want you to go through these examples. So pause the videos and work on it, please. We don't have enough time. I will post a video, and I'll talk about it more on Thursday. All right, but I want you to pause the video for each one of these, write it down on a piece of paper. If it ever loads. Sometimes technology is not my friend. If you want to send something about your biggest struggle with technology in the past week, I would appreciate it. There we go. All right, so this real world problem. So what it is, you're buying apples, all right? So 2 kilograms of apples cost 20 dirham. 4 kilograms of apples cost 40 dirham. So I want you to find what is the cost of 6 dirham. What is the cost? Sorry, what is the cost in dirham of 6 kg of apples? What is the cost for 8 kg of apples. All right, question, how far does Allison travel if she uses 18 liters of gas? All right, so what you have to notice though is that these are out of order, right? These aren't in the order we need. But for every 1 liter of gas, right, that's 1 liter, she can drive 18 kilometers. All right, here are some more equivalent ratios. If I keep saying fractions, I'm really sorry. Sorry, I'm very tired, right? 18 liters of gas then, how many kilometers will she go while driving her car? All right, so pause the video, work on that, please. So on the farm, there are 24 chickens, all right? So on the farm, there are 24 chickens. All right, and for every 3 roosters that you have. Express this ratio in simplest forms. Now we're going to do this one together only because we are struggling with simplest forms. Now remember, I say simplify, I want you to write this out in the lowest common, basically the lowest common values possible. So what can I divide both of these numbers by? 3, right? I can divide this by 3. So just like on the other sides where we were multiplying, finding equivalent fractions, ratios, sometimes you can do that by using division, right? So this is going to become 1 and 8, right? That's a bad 8. 1 and 8. All right, so that means for every 8 chickens, there is 1 rooster. So that is another equivalent. That's another equivalent ratio. Sorry, skip the slide. Just got to go back. Okay, last of the problems. All right, so Jan and John are baking cupcakes for their math class. They are each making an equal batch to split the work. They each need 3/4 cups of sugar. However, John's measuring cup is divided into sections that are each 1 cup. How many 1 cups of sugar does he need to measure his cup equal to 3/4 of a cup? Right. So what you're trying to do is you're trying to compare 3/4 to 1/8. Using numbers, symbols, or words, how many cups of sugar does John need to measure his cup to equal 3/4 of a cup? Once again, we will be going over these on Thursday. I just want you to try these, please. Last one. So what ratios are really useful for is for establishing floor plans. All right. As you can see, all right, so this is a hypothetical question. So it says, let's say we're going to build an addition and add on to our school for next year. So here is a blueprint of what we're kind of thinking about. It's not actually, this is from the textbook. So notice that each square represents a square unit. It's 1 by 1. All right. So what you're going to do is you're going to create, or what we already did, we created ratio dimensions for the rooms below. All right. So in the computer room, there are, we counted 12 different spaces. There's 12 squares. The washroom has 6 squares. That means the computer room to the washroom is a 12:6 ratio. All right, 12:6 ratio. That means for every washroom you have, right, 6 squares, you need to have, for every 6 squares of washroom, you need to have the 12 squares. In our gymnasium, we have 35. In our game room, we have 15 squares. So the ratio for the dimensions of gymnasium to game room is 35:15. The office is 4:8 of the kitchen. So time is almost running out because this video is only going to be 15 minutes. But what I want you to do now is I just want you to work on those 4 practice problems. Hopefully you're done by now. Finish the 4 formative questions. Right? And then I believe you have some Prodigy to work on. And if you are done, these 2 games here are extensions. I know it's working on comparing fractions, but the math is the same. So you can click on this. This link is on the post as well. And you can work on this, do this for a couple of minutes as well. All right? So that's equivalent fractions. Ratios, let me know if you have any questions. Holy smoke, sorry guys. It's ratios, not fractions. Cool.